Hello everyone, welcome to this channel. I will introduce a problem which is CMO problem for 2021 that contains a technique in graph theory which is really useful. Hope you enjoy this video. Hey guys, welcome to this channel and I will share some math contest problem for you, and this is China Mathematics Olympiad, in 2021, the fourth problem. And it said that a conference attended by n scientists. Each scientist has some friends in this conference. Suppose that no matter how we partition the scientists into two non-empty groups, there always exist two scientists in the same group who are friends, and there always exist two scientists in different groups who are friends. A proposal is introduced on the first day of the conference. Each of the scientists' opinion on the proposal can be expressed as a non-negative integer. Every day from the second day onward, each scientist's opinion is changed to the integer part of the average of its friends' opinions from the previous day. Prove that after a period of time, all scientists have the same opinion on the proposal. So in this problem, at first, there is two sectors. The first is the friendship, and the second is the opinions proposal. So at first, we need to consider the friendship. There is a condition that there always exists two scientists in the same group who are friends, and there always exist two scientists in different groups who are friends. So this say that first, when we talk about the friendship, we are easy to think of the groups. That is, let all the scientists be vertex, be vertexes, and if two of them are friends, link with AH, then we have a graph. So what does this condition means in this graph? It was like every two friends, unless how we partition the groups, there are two. So at first, not a bipartite. And this is equivalent to there exists an old cycle. And the second one is that every two, it is link. That is, as said, every two vertex are have a path to are linked by a path. Well, this is easy to say because if it is bipartite, then there has two one, but the points inside of one of the partite, there are no edges and then contradictions. So what about the B if there is two sets where this one? So then we can part them like in this two. Then they have no edges from two of this, and it's contradiction with this because these two different groups doesn't have friends where she which in each group. So these two are right. And let's consider the second one. Opinions on the proposal. Well, this is said that if we have a small example, like that, 2, 3, 4, 1. Then it changes to 3 plus 1 equals 4, and the average is 2. Is that this one forms this, and like this is 3 plus 1, it is 2 either. But this point is 3, and then it happens to in this it is a wrong cycle, because we say that it is it is a peptide because this is this one. So I just tell you, and this is one of the key to this problem, is that this doesn't make the decision to have that all of the opinion on the proposal is have the same, because it is a peptide. So let me make a right example like this, 2, 3, and this then happens to 2 plus 3 is 5, and average is 2.5, so the integer part is 2, and this is 2, and this is 1, and then it turns to 2 plus 1 is 1, 1, 2, and then it turns to 1, 1, 1. So it is okay. So we need to figure out what's the difference between them. It's because it is an odd and it is an even cycle. So how can we derive these things just from the cycle numbers and also the vertices? So you can see that max A1 to AM, AI refers to the first opinion proposal of a scientist, the ith scientist. Then we make this as A, and this just like this, and min is B. Then you can find that if there is A, then it may be displaned. It is every operation A is not increase and B is not decrease. And we make it this as A1 refers to the first operation. After the first operation, the max. So, such as AN refers to after the nth operation, the max of them. So this is what we define here. And back to this problem. So we want to prove this by using the condition of the friendship to prove that A and B is closer to closer. So how can we prove this? Well, we can find that by using this. It's like if this is 2, then this figure out that these 2 points are all 2. So this may be 1, because if there's one like A, then what forms this is that they're all A's. For if it is like A, C, and C is smaller than A, then we have that it is 2A plus C. Well, the integer form actually smaller than A plus C, actually smaller than 2A plus A equals 2A. So this A minus 1, so this can't be A. So if one vertex is the opinion of proposal is the max, Then, while the former version, all of the points neighbor to it is the max. So we can use this like because it is not increase and b is not decrease. So we have that a is max and b is decrease. B is the min. So we have that because a is not decrease and a has the lower band is not increase and a has the lower band is equal to 0. So after and because a is the non-negative integer, so after enough times an will be a constant. So like for any n is greater to gradient and a, the gradient is given and an will be a constant, like just prevent m c, just like this. Then we can use that because this is c, like there must be c, one of them, and we first let at first we can find the old cycle. Find first step 1. Find an odd cycle. Then we cannot sure that all of the points of them must contain a c. So find an odd cycle, and we just let n is equals to t1, which is greater to n, and like because the condition 2 that every two vertex are linked by a path. So in this graph, there must be one point in C. One point in C, and there will be a path linked to one of the points from the L cycle. We just like it as v1, v2 dot vm endpoints. Just like this is vi. So there exists point vertex v. It belongs to the v, which is the vertex of this whole graph, just like that. And exist a path like c u1 u2 uk vi is a path from v, which v is like we tell this as the proposal function f defined from the v to the non-negative integer, which contains the opinion of proposal of the fi is the opinion of proposal of ith scientist. F equals to c, then we have that t1 minus 1. At this time, it confirms that u1 t1 minus 1 f like this. We can use an operation. This is t1 and f t1 minus 1 u1 equals to c by the what we derived before, and after some like t1 minus k we have that f t1 minus k uk equals to c. Then we have that f t1 minus k minus 1 vi equals to c. So we can find t2 as, we denote t2 as t1 minus k minus 1. Then f t2 vi equals to c, and vi is on this odd cycle. So can derive that there exists t2 such that f t2 vi equals to c, which vi belongs to the cycle. Then we will derive something from the old cycle, like this is step 2. In an old cycle, we have that this is 1 of c. Then we will derive that after before sometimes there will be all c in the cycle. Then it's like this cycle is v1 v2 vm, which m is an odd, m is odd. Then we have that like vi, we're with the loss of generality. We just let v1 ft2 is c, then c is vm. Then we derive that ft2 minus 1 v and like ft2 minus 1 v2 is c. But we cannot derive that ft2 minus 1 v1 is c. Then it's like that is c, and then we derive that there's 3c at this time. And after some times we have that there will be like ft2 minus half, well, I minus 1 v, well, 1 plus half m plus 1 equals to c, and f equals to f t2 minus half minus 1 v half m minus 1 equals to c are the same. And at this time it is like the neighbor 2 points is c. Then we derive that. After that, well, it will be this c, 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 c. Then after some times we have that f t2 minus I minus 1. It's back to v1. Yeah, it's back to v1. It's like back to, well, vm, well, how can I say that? v1, just vm, well, just vm, and equals to c equals to, I just write, because this time I just write the abbreviation, and from vm, like this is v1, vm, v2, and all of them are all derived. So from v2 to vm to v2 are all c. Then we can derive that f t2 minus m from v1 to vi for any I equals to c. Then we just let as this, let t2 minus m is also greater to n, greater than n. And like just let t2 minus m is greater than n. Then we have this, and we denote t3 equals to t2 minus m. And when as this the t3 time, we have that one cycle, the main all cycle of this graph is all c. It's strange, or it's magic like. Then after this step, we'll go into step 3 is let all of the points before some all of the points of this graph is all C. Just that for any U belongs to VG, the vertex of this graph, like this, there will be exist VI from the alt cycle. Well, there exist U, well, U1 to UK VI. Yeah, that's this. Here it is. And because we have that, every alt cycle of this, then we have ft3 minus 1. And it's like this point is C, and V1 is also C because of this and this. So I'll write it here. This point is V1, or VI, sorry. And because before one, because this is C, then this is C. And because this one from this and this is also C. So it's like a stack form. That is, when we have this C, and after price, this C will go up, and there will C, well, prime, and after some times, like in this will be up, there will be in one, and up, and in one, and there is infinite, like all. So we have that, these forms, like minus 1 UK equals to C, and after some ft3 minus 1 minus k plus 1 yeah, U is C. Then we have that, and because it is like when it is C, when this is C, then we have that the former one, this is C. Because this is C, so the former one, this is also C. So the chain is like this C, this C, this C. So it is like C, 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 C. And the former one is always C after that, before that. So we have that. This is also equals to, let me change the color. So we have that, all of this chain. And because we choose every U, and K definitely or obviously is greater to n, because there's just only n vertexes. So it is more than. Then we have that T3 minus n must be, well, because T3 is, well, it's much smaller as strictly, so it's like this. Well, yeah, smaller than k plus 1. Then we have that ft3 minus n, that is for any u belongs to the vertex of G, ft3 minus n u is C. Then we just let t3 minus n, just let is greater to the greater than. Then just let here and wait. Where's T1? Here. So this is like, you just need to let T2, T1 minus K minus 1, T1 minus K minus 1 minus M minus N is greater than. Then just let T1 is greater than K plus 1 plus M plus N plus greater N, and that this must exist. So T1 exists, and let every thing as C before sometimes. So we have that the question is finally proved. I hope this video will be beneficial to you, and don't forget to subscribe me. I will introduce more interesting mathematical knowledges and problems in the future. Thank you for listening.